This next video I'm going to cover what I consider to probably be my favorite thing about logarithms, and that's the fact that they can be moved around, manipulated, like changed. There's a lot of amazing stuff you can do. And you guys know, generally when I talk about things being amazing and awesome and beautiful, it just kind of means that they're challenging. But I hope that I can show you through this video and through the next video, which is all about practice, what these properties are. And I'm going to jump right into them. The first property is the one that states that if you have any log, so the log base b, any base you want, of m, plus a log of exactly the same base of something else, you can combine those two logarithms into one logarithmic expression, the log base b, by multiplying what's inside of them. Right? And understand, this thing works both ways, and I'm going to show you the examples in just a minute. It also says if you have a logarithm of something that is a product, you can break that into two logarithms by just taking the log of each of the factors individually. Right? So as a very, very quick example of this one, suppose that somebody asked you what's the natural log of 5 plus the natural log of 7? Well, we can respond that this is the natural log of 35. And you may be looking at that going, wow, big deal. Like, so what? I didn't know offhand what this was or what this was, so why the heck will I know what this is? Good point. On the other hand, you guys have known and seen that in calculus I spent a lot of time talking about how things can be simplified, and so this is one of them. One of the biggest reasons I'm showing you this is that when you've got two parts to an answer, a lot of times it looks nicer if I can write it as just one thing, right? But with that said, we can also use this property the other way. What if somebody asked, is there another way for me to think about the log of 50? And there certainly is. Because 50 is 5 times 10, I could write this as the log of 5 plus the log of 10. And actually, something that's even more interesting about this, when we write a logarithm that doesn't have a base like this, it generally means that it's a base of 10. So this is the log 10, this is log 10. And really, that means that this second one can actually be evaluated. The log base 10 of 10 is what? Well, the log base 10 of 5, there's not much I can do with, but this is just 1. So there's a sense in which we can get an idea of what the log of 50 is because we can break it up and look at it this way. Yay, no big deal. So on to the next property. The next property says that if you've got a log, again, of any base of one number minus the log of another base of some other number, we can again combine it into one thing by this time dividing m over n. Right? I could go through another example or two of this one. I don't know how necessary it is. This one is a little bit prettier to work with, though. You might be somewhat happier with it. Maybe not. If you have the log base b of, I don't know, 75 minus the log base b of 25, well, we know that we can make a fraction out of those things. We could make it 75 divided by 25, but 75 divided by 25 is 3. And so again, there's this idea that if you have two logarithms, you can split it into, you can break it into one logarithm, combine it into one logarithm by dividing the two things that are inside. Yay. I should have done that in green. Oops. So we have two properties so far. We have our addition property that says that if you add two logarithms together, you can multiply what's inside. We have our subtraction property, so if you're subtracting two logarithms, you can divide what's inside. The next property is the most awesome property of all, and that's the power property. This is the property that says that if you have a times a log of any base of something, you can basically take this power and bring it up. So we can write that this is, the log base b of m raised to the a power. Note that this also goes the other way. If you have the log of something with a power on it, you can take that power and bring it down in front of the whole problem, right? This allows for us to do some interesting things, like, for instance, switching to green first, if I have the log base 3 of 2 to the 5th power, right, that means that I can take that 5, the 5th power, and bring it down in front. So I could write this as 5 times the log base 3 of 2. Now again, you may not be very excited about that, but it's a thing that we can do. One comment I want to make here before I leave these properties is it's kind of like the idea that note the two properties up above. These first two properties, this one here being the first property and this one here being the second property, these properties only work when there is nothing in front of the logarithms. Notice that this doesn't have any numbers in front of this log, or this one, or this one, or this one. So if you have stuff in front of the logs, you need to get rid of it. And really, that's one of the biggest places that this property comes in. This allows you to take that pesky number in the front and move it up to the exponent. So as one quick example of this one, if I had 3 times the log base 2 of 3 minus 2 times the log base 2 of 5, we're excited that there's subtraction, which means we can divide things, but I can't do that until I've dealt with these powers, right? So what you can do is you can bring these powers up and end up with the log base 2 of 27 minus the log base 2 of 25. And now, because there's nothing in front of those things, I can write this as 1 log, saying the log base 2 of 27 over 25. And that can be our simplified single logarithm answer. Okay? The one other thing I wanted to cover in this video is the change of base formula, which is something that a lot of people just memorize in intermediate algebra and then kind of don't do anything with it. And I'm hoping to show you more than that today. This formula says if you have the log base anything of some number, you can rewrite it as a log of any other base. So C would be any other number you want by making a fraction, 1 log on top, 1 log on the bottom. And what happens is you take the argument of the log here, this m, and use that one on top, and you use the base of the logarithm b and put it in the bottom of the fraction, base, bottom, b, bottom of the fraction. And there's their change of base formula. Historically, where this was used was, back in the day, calculators didn't have a log base 2 button for them. So if somebody said, what's the log base 2 of 5, you'd kind of just go run and cry. What it means we can do now is you can pick something else. Now, in your intermediate algebra class, they would have picked, let's put the log, like the log base 10, the common logarithm on top. We could do that, but that one's just as weak as the other ones. For us, natural log is the hero of the day. I'm always going to want to write this as the natural log of 5 over the natural log of 2. And this is good for 2 reasons. 1, this thing can be plugged into the calculator. 2, to be honest, you're going to have to trust me. It turns out natural logs are just a lot better. And so in a lot of places, our trick is going to be, let's just rewrite the thing as logarithms and deal with it that way. So for instance, like just a little preview, if somebody asked you to graph the log base 3 of x, a sneaky thing that you can do is actually rewrite it as the natural log of x over the natural log of 3. And the idea is if this may not be everybody, but if you know better what the natural log of x graph looks like, you can do that and then divide it or scale it by this natural log 3 factor. The more I say that, the more you guys are going to call me crazy. But that's okay. We can do that. One last comment I'll make here, and then I'll be done with this video, is that I actually like to use the change of base formula going the other direction. What if at the end of a problem you ended up getting the answer? Oh yeah, the answer is it's the log base 2 of 57 over the log base 2 of 13. Like, yay, I did it. I would like to say there's a prettier way to write that answer. We could write it, if we chose, as the log base 13 of 57. Now, I know we don't even want to think about computing that answer, but the idea is that answer looks really slick compared to this, like, double fraction thing up here. So a lot of times I like to use the change of base formula to get my final answer to look pretty. That's the end of this video. The third video, I was just going to do some practice of all of these things. If you feel like you've got that stuff and you want to dive right into the homework or the assignment and go for it, in fact, I'd recommend that. I'd recommend go into the homework, do some of the problems. If you're getting them, great. If not, come back and watch the third video.